Good evening, everyone, and welcome to our channel Crypto Network. So today's topic is OSPF, Open Shortest Path First. That is a link state, open standard, and dynamic routing protocol. So we'll discuss the key features of OSPF routing protocol, as it can load balance network traffic between multiple paths of the same metric value. It supports authentication using passwords and other methods like MD5. It converts quicker than RIP since routing updates are sent immediately instead of periodically. Uses less bandwidth since transmission takes place only when routing changes occur. Supports the logical grouping of network segments into areas. And since OSPF announces subnet mask, it supports CIDR, variable length subnet mask, supernetting, and non-contiguous network segments. So what is OSPF? So every router is responsible for computing its own best paths to all destinations within an OSPF domain. And once the SPF algorithm selects the best paths, they are then eligible to be added to the routing table. A router running OSPF creates its own database which contains information on the entire OSPF network, not simply neighbors' routes like ARGRP. OSPF routers do form neighbor relationships, though. They exchange hellos with neighboring routers and in the process learn their neighbor's router ID and cost. So neighbor relationship in OSPF. So hellos are sent out periodically on OSPF routers and they form an adjacency with a peer router when it sees its own router ID in the neighbor field of another router's hello message. So we have some sort of mandatory parameters that should be matched, like area ID, subnet mask, hello interval, DAD, stub flag, and authentication. That is the only parameter optional. So in hello packet, we check all these parameters and match all these parameters, and as soon as router 1 receive a hello matches and check the parameters that match, it create an adjacency with the peer router. So next is hello and dead timers. As with many network protocols, hello acts as a form of keep alive or heartbeat. With OSPF, if 4 consecutive hellos are not received, the router is considered down. Point-to-point interfaces, hellos every 10 seconds, dead time is 40 seconds, and non-broadcast multi-access NBMA interfaces, hellos every 30 seconds, and dead timer is 120 seconds. You can manipulate the hello and dead timer on per interface basis. Alright, so we have OSPF states in order to form a relationship with the peer router. So to get through these 7 states to become neighbors, the first state is down state, where no OSPF neighbors detected at this moment. Init state, hello packet received from one router. Two-way state, own router ID found in received hello packet. Start state, master and slave roles determined. Exchange state, database description packet are sent. Loading, exchanging of link state requests and link state updates packet. And finally the full state, So OSPF routers now have an adjacency, full neighbor state. So what are the advantages of an area in OSPF? So imagine an enterprise network with 900 routers and several thousand subnets. The CPU time to run the SPF algorithm on all that topology just take time, and as a result OSPF convergence time can be slow. The solution is take the one larger link state database and break it into several smaller LSDBs by using OSPF area. So with areas, each link is placed into one area. A smaller link state database, fewer routers, exchanging LSAs that minimizes processing and memory requirements. A smaller routing table, like we know that summarization is not happen by default. We have to manually summarize. So the smaller routing table entries as network address can be summarized between areas. By specifying area, you can create different independent networks which connect to area 0 via area boundary router ABR to communicate outside other areas. Less frequent SPF algorithm calculations localizes impact of a topology change within an area. Alright, so we have different types of routers in OSPF, mainly, or you can say specifically 4 types of routers. So they are internal backbone area border router and autonomous system boundary router. So backbone router, at least one interface assigned to area 0. We have internal routers, all interfaces in a single area. Area border router have interfaces in 2 or more areas, and ABRs contain a separate link state database, separating link state advertisement flooding between areas, and optionally summarizing routes and optionally sourcing default routes. We have another flavor, that is autonomous system boundary router, that has at least one interface in an OSPF area and at least one interface outside of an OSPF area, meaning redistribution. So one interface is in OSPF domain and another interface is in another routing domain like BGP or AIGRP, etc. So we have different types of area in OSPF. We have backbone area, backbone area, another name of area 0. So area 0 is known as backbone area in OSPF. Regular area. So regular area is a non-backbone area with both internal and external routes. Stub area, so contains only internal routes and a default route. Totally stubby area, that is again a Cisco proprietary option for a stub area. Its database contains routes only for its own area and a default route. So we have not so stubby area, contains internal routes, redistributed routes, and optionally a default route. We have totally stubby, not so stubby area, where the totally NSSA is same as the NSSA, with the addition that it blocks inter-area routes. That means no type 3 or type 4 summary LSAs are allowed. So we discuss more on LSA types in few minutes. Totally stubby and totally not so stubby, both are Cisco proprietary area designations. Alright, so we have OSPF route types and preferences. So the order of the OSPF path selection, regardless of a route metric or administrative distance, OSPF will choose routes uh, in an order, and the order is intra area routes are preferable over inter area routes. Inter area routes are preferable over external type 1 routes, and external type 1 routes are preferable over external type 2 routes. All right. So what are DR and BDR? What are the roles of designated router and backup designated router in OSPF? So based on the network type, OSPF router can elect one router to be a designated router and one router to be a backup designated router. In multi-access broadcast network such as LANs, routers default to elect a DR and BDR, and DR and BDR serve as the central point for exchanging OSPF routing information. Each non-DR and non-BDR, like the druthers, DR others, so we'll exchange routing information only with the DR and BDR instead of exchanging updates with every router on the network segment. So here DR will then distribute topology information to every other router inside the same area, and that greatly reduces OSPF traffic. To send routing information to a DR or BDR, the multicast address is 224.0.0.6, and DR send routing updates to the multicast address of 224.0.0.5, and if DR fails, a backup designated router takes over its role of redistributing routing information. So we have two rules in order to elect a DR and BDR. So one is a router with the highest OSPF priority will become a DR, and the router with the second highest OSPF priority or router ID will become a BDR, backup designated router. So by default, all routers in OSPF have a priority of 1, and if there is a tie, a router with the highest router ID wins the election. You can influence the DR and BDR election process by manually configuring OSPF priority. This is done by using the IP OSPF priority value command, interface command, like on interface basis. So changing the priority to 0 will make the specified router or routers ineligible to become a DR or BDR. So let us discuss the election of router ID. What is router ID? So OSPF router ID selection algorithm works like each router selects a router ID. The process is any manually configured OSPF router ID in OSPF process is selected as the OSPF router ID. So if you manually configure router ID with the router ID command under OSPF process, so that router ID will elect as a router ID in OSPF process. And if there is no OSPF router ID configured, so the highest IP address on any of the router loopback interfaces is elected as the OSPF router ID. Finally, if there is no loopback interfaces configured, the highest IP address on its active interfaces is elected or selected as the OSPF router ID. So let's continue by looking at the different OSPF packet types. So we have hello packet. So hello packet is a neighbor discovery packet that build neighbor adjacencies and maintain them. Second is database descriptor. This packet is used to check if the LSDB between two routers are same. The DBD is a summary of link state database. Link state request that request specific link state records from an OSPF neighbor. Link state update sends specific link state records that were requested. This packet is like an envelope with multiple LSAs in it. We have another flavor, link state acknowledgement. So here OSPF, as we know, is a reliable protocol. We have a packet to acknowledge the others. Right, so summarization, OSPF has to compute the best path to every destination within its area, and avoiding running the algorithm wherever or whenever it is not required is a big win. OSPF does not support auto summarization, only manual summarization could happen. OSPF can only summarize our LSA type 3 and 5. OSPF route summarization can be of two types. One is internal route summarization and external route summarization. You can do internal route summarization on only ABR between areas. The reason for this is that link state database for all routers in area must be the same for that area. And to configure OSPF summarization, go to the ABR under OSPF configuration mode and use area ID, range, address and mask. Quite simple. So another is external route summarization. So external route summarization is specified specific to external routes that are injected into OSPF via redistribution. That's why external route summarization must be configured on ASBR. So the configuration is here simple, quite easy. Under OSPF process, we have to enter summary address with the summary of the network and the mask. That's it. So summarization, one should know the summarization, how we summarize the route in order to perform these activities. Okay, so OSPF default routes. There are multiple ways to inject default routes into OSPF, and Cisco recommends the default information originate command under the OSPF routing process. And if you use the default information originate, you can advertise a default route in OSPF. OSPF won't advertise a default route if you don't already have it in your routing table. And if you add the always keyword, default information originate always, so always keyword, it will advertise the default route even if you don't have it in the routing table. Fine. So OSPF virtual links, that is one of the main topic. So all areas in an OSPF autonomous system must be physically connected to the backbone area 0. And in some cases where this physical connection is not possible, you can use a virtual link to connect to the backbone through a non-backbone area. The area through which you configure the virtual link, known as a transit area, must have full routing information. The transit area cannot be a stub area. We have to configure like area under router OSPF process, area ID, virtual link, and the virtual link ID, the router ID of a neighbor router, of an ABR router. So the router ID should be the router ID of that neighbor router, It would not be the IP address of the neighbor router or associated with the virtual link neighbor. So here in our example, we have ABR 1 and 2. So area 1 under ABR router 1 OSPF 20 process, area 1 virtual link 10.30.30.30 is the router ID of a neighbor ABR router ID. Same in ABR2, we have virtual link 10.50.50.50 is the router ID of a virtual link neighbor. Fine. So now OSPF LSA types. So LSAs build up of the OSPF link state database, and they are exchanged between OSPF enabled nodes. So we have a list of OSPF LSAs here and a short description. So we have one type router LSA that contains router links and states and is flooded into the area of origin, so within an area. We have type 2 network LSA that is generated by designated router and list all attached routers and flooded into the area of origin, you can say within an area. We have another variant, type 3 network summary LSA, that is generated by area border routers sent into an area to advertise prefixes to other areas, flooded throughout the autonomous system. We have type 4 ASBR summary LSA as well, generated by autonomous system boundary router ASBR and advertises external destination. Advertises the ASBR, not the external destination. So advertises the ASBR router ID. So where the router ID, so who's the ASBR and what is its router ID, so that ASBR summary LSA type 4 generate and flood and flood throughout the autonomous system. So we have type 5 external LSA that generated by ASBR and advertises external destination. So ASBR ASBR advertises the routes that I have to the internal OSPF to the ABR, flooded throughout the autonomous system. So LSA type 7, that is external LSA, also known as not so stubby LSA, NSSA LSA. So NSSA external LSA packets are used for not so stubby area that do not allow external distributed routes to go through and block LSA type 5 packets from flooding through them. LSA type 7 packets act as a mask for LSA type 5 to allow them to move through these special areas and reach the ABR that is able to translate LSA type 7 packet back to LSA type 5 packets. So finally, we configured OSPF and time to troubleshoot and verify. So we have show IP protocol, show IP OSPF process ID. So show IP OSPF provides information about the OSPF process and its details. Show IP OSPF database that provides information about the contents of the topological database. Show IP OSPF neighbor displays all the information about the relationship that the router has with its neighbors. We have show IP interface that provides information on how OSPF has been configured on each interface. So that is all in this video. I hope we have covered most. Rest we will continue in our upcoming video, where we will deep down into the OSPF configuration and the learning. So thank you very much for watching this video, and I would like to say thank you to Cisco, to you all, and have a wonderful day. Bye bye. God bless.